Hello 108 students, Mr. McHugh back with you here on section 8.5. Going to wrap it up here on page 3, and we've been working with rationalizing denominators, and now we're going to handle a case of what happens if you get a binomial in the denominator and it has a radical in it. Okay, first when you think about it, you're like, I don't know, I wouldn't have a clue what to do with it. And then what I'm hoping we've seen from the previous videos on our class notes is when you have a binomial and you multiply by its conjugate and you got radicals in it, the radicals go away. And that's because of, you know, something like the square root of 5 times the square root of 5 is the square root of 25, and you execute the square root of 25, you get 5. I like to say it boomerangs back the radicand. Okay, so we've seen that, and so let's try some examples of that. And so you have a binomial. If it has one or two radicals in it, the good news is you can use the difference of squares. Now you can still use FOIL, but get comfortable with the difference of squares because it makes life just a tad easier. Take the first term and square it. What's 1 squared? 1. Take the second term. What is it? The square root of 2. And you do what with it? Square it. What happens when you have a square root and a squaring? Okay, you could tell yourself they negate each other. I like to use that phrase. So you're left with 2. 1 minus 2, final answer is -1. Okay, so how can we use that? Let's work our way through a couple examples here. 5a starts us off with, this is the original problem right here. And in the denominator you got the binomial 4 minus the square root of 3. Remember, you want to train your brain to find the reads. You're Kellen Moore. What are you going to do with this problem? You know you can't have radicals in the denominator. You're supposed to rationalize it. It's a binomial. Take a binomial, think of its conjugate. Okay, it's the binomial where the signs go from minus to a plus. So that's what you're going to multiply. That's your driver, and you remember, oh yeah, anytime I multiply radicals times radicals, it gets rid of the radical sign. But you got to stack it. Anything divided by itself equals 1. That's how you keep you don't mess with the problem. You multiply equivalency by 1. Okay, so go ahead and do that. When we multiply numerators and denominators, we go across the board. 5 times the parentheses, 4 plus the square root of 3. You'll leave it alone for now. Okay. Now down in the denominator, what's going to happen here? Difference of squares. Take the first term, square it. Take the second term, square root of 3, and square it. Okay, what's your results? 4 squared is what? 16, and square root of 3 squared. Square root of 3 squared. They negate, and you're left with 3. 16 minus 3 is 3, and you're left with that. Oh, underneath the numerator, which is 5. Now, leave this in factored form. You might be tempted to multiply that out, but they want to see that in factored form. So you just leave it like that, and you're done. Okay, try another one. Look at 5b. Let's move it down just a little bit. 5b. Here's the original problem. Focus on the denominator. Oh, you got 2 radicals in there. It's 2 terms. It's a binomial. So again, you multiply by its conjugate. You write it down. Look at the signs. Go from positive to negative. Stack it because it equals 1. And now execute the nitty-gritty details. Go across the numerator. Oh, what happens when you multiply a binomial by another binomial? You do FOIL. Okay. And you're going to get first is 2 times 5 is the square root of 10. Inner 3 times. When I say 3 times 5, you know I got the radicals. Negative square root of 15. Outer or last. Outer 2 times negative 3 is negative 6. Last, negative 3 times negative 3 is 3. Okay, you'd get the square root of 9 to execute the square root, and you'd get 3. Okay, now can you combine anything up here? No, so you leave the numerator alone. What's happening down here? You're multiplying by binomial by its conjugate. We've already said that. Take the first term, square it. Square root of 5 squared gives you 5. Square root of 3 squared gives you 3. Okay, now you could over and over again, you could say 5 square root of 5 times the square root of 5 is the square root of 25. Execute the square root of 25 is 5. You get tired saying it. Recognize Square root and squaring undo each other, leaving the radicand. Now 5 minus 3 is 2 and you're on your way. Okay. So example C, looks like I did a retake on that when I started writing my notes up, so try not to look at this crazy stuff here. Just got a little confusing, so we started off clean. Okay, down in the denominator, you've got a binomial with radicals multiplied by its conjugate. Okay, so what does that mean? Difference of squares. Square root of 5 squared would leave you the radicand. There's the 5m. Square root of p squared would leave you the radicand. There's the p. There you go. There's the short way to do those. Now, you had to stack it. Oops, where's my mouse at? You had to stack it. The terms, like we did before the conjugate, you had to stack it. And you take in 3 times the quantity, square root of 5, square root of 5m plus the square root of p, and that is your answer. Again, they like to see everything in factored form. You do not distribute to 3. Okie dokie. Now, last section for the whole chapter, for the whole section of 8.5. Objective 4, lowest terms. Here's a deal where they've given you terms up in the numerator, they've got radicals in the denominator, they've got a 4. Okay, now, can you simplify this? And the answer is yes. You could look at this at one way and take the shortcut, say 6 and 4, reduce that as a fraction and write 3 halves. And then say 2 fourths and see it as a fraction or write it as 1 half. You could put the 1 here just to see that. And then you've got a common denominator of halves, so you keep the denominator, the LCD, and you get negative 3 plus the square root of 5, and that's your answer. Okay. Now what I did over here was I wrote every term up in the numerator divided by the denominator to expand that if you want to see it. So there's your 6 divided by 4 is 3 halves. 2 fourths is 1 half, like we said, with the square root of 5. Okay, so I have one last note here, strong recommendation. Always factor the numerator denominator first, then simplify. We will see this in chapter 9 when we get to quadratic equations, so just a little tip there. And I think that's all we got to cover. So guess what? Section 8.5 in the books, page 3 done. So we're cruising. It's a long, chapter 8's a little bit long. When I see you for section 8.6, we're going to work solving equations with radicals or radical equations. We're going to solve those. So looking forward to seeing you guys on page 1 of section 8.6 on the next video. Okay, bye.